Hey, what's up? It's Jake from Nimbus DevOps, and now I'm going to cover context managers. So, when you're working with an external resource or a global state, you often need to perform some cleanup steps. It could be like releasing resources or restoring original state um, whenever you're done, right? But failing to clean that up could result in all kinds of bugs. So, we need to ensure that our cleanup code is executed even if an exception happens. And you could use the try finally statement, which is probably what you're thinking right now, but it's not always convenient and could actually result in a lot of repetition. So, as we often have to perform similar cleanup steps whenever we work in a particular type of resource, context managers solve the problem by creating an execution context in which we can work with. And that'll give you a resource or a modified state and automatically perform any necessary cleanup when you leave that context, even if an exception was raised. So one example of global state would be that we want to modify temporarily is the precision for decimal computations. Okay, so let's suppose we need to perform a particular computation for a specific precision, but we want to retain the default precision for the rest of our computations. So it might look something like this. So from decimal import context decimal get context and set context. And then let's make 1 equals decimal 1. Okay. And then we'll make 3 equals decimal 3. So original context equals get context, and then ctx for our context will be just context of precision equals 5. And then we're going to set our context to context and print our context. Then we can print 1 over 3. We can set our context again to our original context and then print 1 and 3 like that. And notice that we store the current context, set a new context with a modified precision, perform a calculation, restore the original context, and running this will give you some interesting output. So let's try this. So Python decimal context. Okay, precision 5, rounding, round half even, have an emin, an emax, capitals, like there's just like a ton of information, right? But what we see is that when we set the context with a precision of 5, I get 5 places, right? So I've got 1, 2, 3, 4, 5 decimal places to the right of the decimal point. And when I set the context to the original context, which is just the way it was before I defined it, you'll see I get a whole bunch of decimal places. So this seems fine, but what if an exception happened before you could restore the original context? So you'd be stuck with the wrong precision, and all the results of the subsequent computations would actually be completely wrong. You can fix this using a try finally statement. I mean, under set context, I could be like try, and then take these two guys. Hey, get over here. These two guys. Try to do this, and then like a finally, you might be thinking like, oh, well, that solves the problem, right? That is much safer. So now you can be reassured that regardless of what happens in your try block, you'll always restore the original context. It's not very convenient to keep having to write like try finally blocks like this. And this is where context managers come to the rescue. So the decimal module provides local context manager, which handles setting and restoring context for you. So that would look like, so I could do like uh, with local context precision equals 5, and then I'll just say as context, and then print my context and print 1 over 3 like that. And then on the outside, I could also say print that, right? So this is a lot easier. So I can take all this and I can just be like, go away. And we can just do that. And what happens when we run this now? The exact same thing, but less code. It's also possible to combine multiple context managers in one statement. It's pretty useful for situations where you need to work with multiple resources at the same time. So what you could do is something like with local context, and then run the same thing, your context with your precision of 5, but instead say comma open and then some file like out.txt, and we're going to write to it, write as out underscore f for file, and then out underscore f dot write, and then in quotes I could put like 1 divided by 3 equals 1 divided by 3, like this, and then give myself another carriage return. So here we enter the local context and open a file which acts as a context manager in 1 with statement. We perform a calculation, write the result to a file. When we're done, the file is automatically closed and the default decimal context is restored. You don't have to worry about the details of working with files. I'm going to do that next. But apart from the decimal context and files, many other objects in Python's standard library can be used as context managers, like a socket object, which implemented low-level networking interfaces can use as context managers to automatically close network connections, or lock classes used to synchronize in concurrent programming use the context manager protocol to automatically release locks. So throughout the rest of this section that I'm going to do, I'm going to go over implementations of context managers, but I just want to just explain what it was before we get into anything more complicated.